Hi there, today we're going to be doing number 16 of John Abbott College's NYB Chemistry Sample Final Exam. Number 16 is asking us to find the balanced molecular and net ionic equations for the reaction between the following pair of reactants. So in A we have sodium phosphate and calcium chloride. Sodium is Na and it has a charge of +1. Phosphate is PO4 and it has a charge of 3-. So to have a total charge of 0, we're going to need to add a coefficient of 3 in front of the Na to have a charge of 3 plus to neutralize the charge of 3 minus, which gives us Na3PO4, and it's going to be in an aqueous state. Calcium chloride. Now for calcium chloride. Calcium has a charge of 2 plus, and chloride has a charge of -1. So to have a neutral charge, we're going to have to add a 2 in front of the chloride to make it 2-, which will neutralize the charge of 2+ of calcium. This will give us Ca2+, also in the aqueous state. Next, we have to look at our solubility table to determine which reactants are going to create a precipitate. If we look at calcium chloride, it is soluble, meaning that there will be no reaction. Sodium is soluble with everything, so sodium chloride and sodium phosphate will both be soluble, meaning that there will be no reaction. Now for calcium phosphate, there is an I, meaning it is insoluble, and that there will be a precipitate that is created, and that there will be a reaction. So for the molecular formula, we start by writing our two reactant pairs, which is sodium phosphate and calcium chloride, both balanced as we did in the first step. And in the previous step, we determined that the precipitate created will be sodium phosphate. So we can simply write sodium phosphate, and that will be solid. And the two ions that are alone after that is sodium chloride. So we're just going to write sodium chloride. And sodium chloride will be the spectator ions because they did not react in the reaction. So now that we have this is a good answer, but it's not the full answer because the question asked us to find a balanced equation. So to balance this equation, we need to add some stoichiometric coefficients. So we have we have 3 NAs on the left and 1 NA on the right. So then we can necessarily assume that there will be we're going to have to do something on the right side to sodium chloride to get more Na. So let's try balancing this left side first. So let's add a 2 in front of here, which will give us 6 Na and 2 PO4. And then because we have 6 Na, we're going to have to add a 6 there. Just add a 6 right here. And because we have a 6 there, we're going to need the 6 chloride. But then we're going to have to add a 3 here. So then, now that we have this, we can start canceling some things out. So because we have 6 Na, we can cross out the 6 Na. Because we have 6 chloride, we can cancel the 6 chloride. So this part of the equation is done. This is done. And this is done. Now but something's going to have to change for the calcium phosphate because now we have 3 calciums and we have 2 phosphates. How are we supposed to write that? Well, we're not going to be able to add a coefficient in front because we don't want to use fractions, because if not, it will give weird numbers. So then to get the right answer, we're going to have to rewrite this equation, this part of the equation right here, by adding subscripts. So then because we have 3 calciums, we're going to write Ca3. And for phosphate, we're going to add a parenthesis because it's a compound. And we want it to the whole part of the compound. So it's PO4, and we're going to add a 3. And this will be in a solid state. And that is the first part of 16, the molecular equation. Done. For the net ionic equation, it is very similar to the molecular, but we take out the spectator ions, which the spectator ions in A were they were sodium chloride. So we take out the sodium chloride out of the equation. So to get the whole goal is to get the precipitate as a product. So we just write our calcium phosphate nicely balanced right there. And then we want to get that as a product, so we just write a reactance of calcium and phosphate. Calcium has a charge of 2 plus, that it's going to be aqueous, and then phosphate has a charge of 3 minus. And it will also be aqueous. And there we go, that's the net ionic equation. So now for part B, we have nitric acid and sodium carbonate. This type of question is when you're reacting an acid with a carbonate compound, and you will practically always get the same sort of answer, meaning that you're always going to have, for the molecular equation, you're always going to have your acid, and then you're going to have your carbonate compound. So in this case, we have nitric acid and you have sodium carbonate. Your products will always be, you're always going to have carbon dioxide and you're always going to have water. So you can necessarily write those right away. And you just have to determine what's left in the equation that hasn't been, that doesn't have that's not going to be transformed into carbon dioxide or water. And in this case, it's going to be sodium nitrate that's not going to be transformed into water or CO2. So then you're going to have to add a coefficient of 2 in front of the nitric acid to balance the equation. And then because you have 2 nitrates, you're going to also have to add a 2 in front of the sodium nitrate to balance the equation. And the net ionic equation is fairly simple. You're always going to have CO2 and H2O as your products, so you can necessarily write those right away, and you need to find what's going to give you those as products. And the reactants you're going to need is, you're obviously going to need the acid, and which in this case is 2H plus. And then you're going to have obviously carbonate, because that's the type of question this is. It's an acid reacting with a carbonate compound. So you're going to have carbonate, which is CO3, 2 minus. And they're both going to be in aqueous state. And you're going to have to add a 2 in front of the hydrogen, because hydrogen has a charge of +1 and carbonate has a charge of 2 minus. So to balance it out and neutralize this equation, to give it a charge of 0, you're going to have to add a 2 in front of the hydrogen. And there we go, that's the molecular and net ionic equation. And that's number 16 of John Abbott College's Chemistry NYB sample final exam. Thank you for watching. See you in the next video.